Hi, I am Fabrice Defessant from OCaml Pro, and this talk is about OPAMBin, or how to use binary packages with OPAM. Let's start with some motivations for this work. So there is a very nice feature of OPAM called local switches that is very useful. If you are in a project, you can call OPAM switch create dot in the project to create a switch that is local to the current directory. And you will be able to install the dependencies of the project on the project packages inside that switch. That's very similar to what other package managers like Cargo or NPM do. However, the problem is that you end up with many copies of the same compiler or packages, the popular packages like Dune or libraries that are used by many packages. They are all installed in every local switch that you create, so you end up with many such directories. So the problem is that for every copy, it takes a lot of time to build, and it takes a lot of time and a lot of space on disk. On my computer, one switch is usually more than 1 gigabyte. Also, if you don't use local switches, but only one switch, you will anyway spend your time building packages, removing packages, reinstalling other packages, and then if you switch back to the initial project, you need to reinstall the former packages, and every time you do that, it takes a lot of time to build the packages. Of course, it takes less disk space, so it's a compromise between them. Also, there is a nice interaction between binary packages and continuous integration. For example, if you have a CI that creates nightly builds of your project every night, you can use it to create binary packages and push them on a repository. That way, users can download these binary packages and use the most recent version of the project every day without needing to build it. That's a quite popular mechanism used for some other languages like Java, and I think it could be very useful to use it when, for example, you use OCaml as a small part of a bigger project. Then it makes it easy for all the developers and all the users to use that part without needing to build it and to have a toolchain installed. Finally, there is already a script called OPAMBin cache in the OPAM sources, but from that point of view, it's not good enough because the binary packages that are created are not relocatable, so you cannot use them in different switches, for example, in different local switches, and also there is no easy mechanism to share these packages between different users. So we did OPAMBin to try to solve all these issues. So when a package is installed using OPAMBin, it is automatically patched. So there is a patch found in a set of patches that is found on GitHub that is applied to the package, and it makes it relocatable, so it can be moved on the disk and installed anywhere. A binary archive is automatically generated also from the artifacts of the project. When the package is reinstalled, then the binary archive is used instead of compiling again the package. Then OPAMBin also creates an OPAM repository where it stores all the generated binary packages so that other users can use these packages on their computer, and even without using OPAMBin, just by using OPAM. Finally, OPAMBin has a mechanism to detect identical files installed in different switches and makes hard links for them so that you only have one copy of every file in all your switches. So it saves a lot of disk space. So let's see a few steps of a standard usage of OPAMBin. The first step is to install OpamBean and configure it. So usually you just need to use Opam and install OpamBean from the official repository of Opam, and then call opam-bean install for OpamBean to configure itself. So here we can see that Opam has installed OpamBean, and then when OpamBean is started, it's going to create a configuration file. It's going to copy its executable within the .opam plugins directory, so that it doesn't matter in which switch you install OpamBean, it will be able to use it from any switch. It's also going to check for Opam hooks and change the configuration of Opam to call OpamBean every time a hook is called. Finally, it downloads the current set of patches for relocation of the OCaml packages. Now we can check the configuration. So we can call opam space bean space config. The reason for that is that Opam uses it now as a plugin, so it can be called from anywhere using this notation. And this command will display all the options of the current configuration of OpamBean. Of course, all these options can be configured, can be changed by calling these options, this subcommand with the correct arguments. Now let's try to install a switch with OpamBean. So here I'm just calling Opam, switch create with the version of a compiler. So OpamBean is going to print a message showing that it is active, that it has the option to create binary packages and the option to share files between switches. Then Opam is going to install, to build and install all the packages. And OpamBean at the end is going to print a message showing what it did during those installations. So it created here a set of packages, binary packages, and for every package, so there is a bean package that has been created with a version containing 2 hashes, 1 hash for the sources and 1 hash for the binary part created. So we see that building all these packages took a lot of time, a bit more than 3 minutes, just for building the compiler. Now let's reinstall this switch. So we remove it and we create it again using Opam switch create. So we could have called it with a different name, it wouldn't have mattered. OpamBean is still active. And now let's see what has happened. So here OpamBean tells us that instead of building the packages, it used the archives that it found, the binary archives that it found in the cache. We can also see that it took very little time, a little more than 30 seconds to install all the packages instead of more than 3 minutes. So it's quite efficient. So now let's have a look under the hood. So OpamBean benefits from a feature of Opam called hooks. So these hooks are currently mostly used for sandboxing. There are commands that are called at different steps during the installation and removal of packages. So there are 4 families of hooks. There are session hooks. So these hooks are called before and after a session. So before any Opam command, whether you install, whether you update, whether you remove. There are hooks for build commands that are in the Opam file. So there are commands that are called before, after, and for every command in the build file, in the build list, there is a wrapper called the command. And that's the part that is, for example, used for sandboxing. So there is commands like that for the build steps. There are commands like that for the install steps. And of course, there are commands like that for the removal steps. OpamBean uses most of them. I put in parentheses the free ones that are not used. So you can see that it makes a very high use of this switch, these hooks. So if we have a look at the configuration of Opam after the installation of OpamBean, we can see that, for example, for the pre-build hook, Opam is going to call OpamBean, the pre-build subcommand with a name, the name of the package, the version of the package. If the OPAM file is defined for this version of OPAM, then an argument for that, and the list of dependencies of the package, and so on for all the hooks that OPAM bin uses. Now, if we have a look at every step, in the pre-build step, the OPAM bin is going to check simply if the package that it's trying to build is already a binary package, in which case it has nothing to do. So for that, we have a file that we put in every binary package that is called binpackage.version. And if that file exists, then OPAM bin doesn't have anything to do. If it is not the case, then we are going to locate a patch for the relocation of the package. So if there is one, we check the version and we try to use a patch that has a smaller version than the current version, so that, for example, if you have many versions of a package, you may only need one patch for all of them. So that's quite often the case for many packages. Now that we have patched the sources, we are going to check that all the dependencies have been installed as binary packages. That's very important because for the consistency of binary files, we need a binary archive to be created only if all its dependencies have also binary versions. Otherwise, we'll end up with inconsistent assumptions. Then we also need to have the OPAM file for that package. So either it was provided as an option, or we will call OPAM to get the current version of the OPAM file that is being used for the installation. So using this command OPAM show. Now we will compute a source hash. The source hash is composed of two parts. There is one part that is the package UID, which is the hash of the sources on the OPAM file. So that's the part that is related to the package and to internals of the package in some way. And then there is the dependency part, which is composed of the name, the version of the package, and all its binary dependencies, including their source and binary hashes. That way, we have a unique identification of the package, of the state of the package, and we can try to see if for that source hash, we have currently a binary package that exists in the cache or in the repository of binary packages. If we found an occurrence, then if it is remote, we can download the archive, and then we extract the files in a local directory called bin cached. And then, because OPAM bin is going to be called at every step of the installation, we need to save the current state in a file, what we call a marker, and that is stored in the local directory that will be used for the next steps to know what OPAM bin has to do. So for the wrap build subcommand, which is called for every build command in the OPAM file, we just need to check that we will only execute the build command if they are needed, which is when if there are no binary archive that was found for this file, for this package. Now that we have built the package, we are going to check in the pre-install step if there is a bin cached subdirectory. If it is the case, it means that we have found a binary archive in the cache for that package. So we just need to copy all the files from the bin cached subdirectory to the OPAM switch prefix directory. Now, wrap install subcommand is the same as wrap build. We only execute the commands if it is needed, which is if there is no binary archive in the cache. Then, in the post-install step, we only do something if there was no binary archive. Then we have to create a binary archive for this package. To do that, we start by building the archive of the files. There is a very convenient feature of OPAM for that, because it knows which files have been installed. So we can ask OPAM to provide the list of files to include in the archive. Now we also compute the binary hash of the package, which is the binary hash, the hash of the binary archive, and we can generate the final name of this package, which is the package, its version, plus the bin suffix, the source hash, and the binary hash. The first part, until the source hash will be used to locate binary packages in the cache, and the other one is used to make unique the dependencies between binary packages. Now that we have everything, we can create the OPAM repository part of the package so that it can be used by other users. So for that, we need to build a package directory in the OPAM repository. We create an OPAM file for the binary package, and we only add two small meta information files. One is the bin package version that is used as a marker for binary packages when calling OPAM bin, and one is some meta information that is, for example, used by the OPAM bin search command. Now, if we want to share our repository of binary packages, we need to configure two options. One is to tell the user where they should download the archives, the binary archives. So we need to provide the URL of the website as the base URL. So this command is going to patch all the OPAM files in the repository to use this URL as a source for the archives. We also need a second option to tell it where it should copy the repository, but this time using rsync and SSH instead of a URL. So these two URL actually are for the same server, but one is the website and the other one is through SSH. Now we can use OPAM bin pool. It's going to download the current state of the OPAM repository as it is seen by other users. We can install some packages. The binary packages for these packages will be added to the repository automatically. And then we can use OPAM bin push to push the new packages to the website using rsync. So if we have a look at what does OPAM bin push, for every subdirectory so there is a directory store where OPAM bin put the OPAM repositories it creates, and then we can, for every one of them, it will call OPAM admin index that creates an index used by OPAM when it has to download a repository. We will generate an index.html file to make it easy to browse the content of the repository, and it will push the files to the website using rsync. So if we have a look at the index.html file, you can see that all the packages that we created before are there. Actually, for every package, there are two packages created. One is the binary version of the package, and one is a package plus bin. That means that, for example, if you want to really force the use of a binary package instead of a source package, you can use this new package name so that it will force the installation of the binary version. Because depending on the dependencies, you could have a case where you download a source file, a source package, and there is no binary package with the dependencies. So if you force the binary version, it will install packages for which it has no binary version, and it forces the installation of binary dependencies. So for a given file, for example, if you look at OCaml-based compiler, you can see its version. You can see the archive is about 200 megabytes, but it will install about 500 megabytes on the disk and more than 2,000 files. Using the meta information files, we can use the OPAM bin search command. With this command, you can search files, a bit like apt file. You can see which archive contains a given file. You can see which archives depend on a particular package. And you can also know the size of the packages when they will be installed. There are a few limitations. For example, today there is no support for side effect packages like the confstar packages. So we think that OPAM needs to provide a way for OPAMBIN to deal with such packages. It's not clear what we have to do also. OPAMBIN also uses the hooks, but for now, when it does it, it disables sandboxing. So we need to find a way to be a little more clever, to have OPAMBIN and sandboxing working together. And finally, most OPAM packages in the current repository do not correctly tag their dependencies as build dependencies. So actually, binary packages could have much fewer dependencies that they have if these tags were used correctly. So thanks a lot for listening to this talk. So I hope you will try to use OPAMBIN and see if it works well for you. And if you want to contribute, the repository, the project is on GitHub, and so you can help us by providing feedback or contributing new features. Thanks a lot.